got this picture back in here. So again, these are moles amount of something. And here's a better version of Avogadro's number right here. So this is a discrete amount. You can say a mole is an amount in which there are this many, you could say atoms, you could say molecules, you could say ions, you could say anything, but it's a discrete amount of something. Is it a good way to count eggs or sand? Let's look at what happens when you try to count something. This is great. So in class, we're going to keep watching this video, but this makes it really easy to understand why it's not practical to talk in a large amount. But you see how the grams correspond to moles. So, is it a practical way to count eggs? Well, eggs aren't that hard to count. Like, even if you have a whole lot of eggs, you probably aren't going to be counting them in that kind of a quantity. Even sand, in fact, won't be counted in this amount of quantity. We're talking about something way, 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 way smaller than sand. Way smaller than like a garbage truck full of sand. The atoms are so much smaller than sand. So remember, all moles is this many, and these are all atoms. In this case, we're talking about atoms. And so this is showing you what atoms look like, that many atoms of different substances. Now, if you look on the chart, and this corresponds to everyone, but we have a few of them that are easy to see. This chart just isn't rounded, but 28.1, 28.1. So that number is recorded on the chart. 207, 207.2. So see, that number is on the chart. 10, that number is on the chart. So this chart tells us that in basically the square that this element is in, the square is like saying 1 mole of this element, and then this is telling us how much it weighs. So if I were to take 1 mole of this element, it's going to weigh that much. If I take 1 mole of gold, it will weigh this much. So the periodic chart tells us a lot of information about grams and moles and what they are. And here's just some example reminders. So if we take that number of lead that's in the picture over here, that picture, we know it contains this many atoms. That's the same thing as saying that is 1 mole, which is the same thing as saying this is how much, this is what the mass of it is when you put it on scale. So we're going to do a factor label example, and then you're going to practice with the factor label examples. Convert grams of lead into moles of lead. So we have a gram here and a gram here. Remember, that's because we write down the only unit we have, and then we cancel it by putting it diagonally downwards. And you saw up here, 1 mole of lead has this mass. And again, that's from this number on the chart. The 1 in chemistry often goes with the word moles. Chapter 2, there's a chapter 9, you'll actually see a difference in that. And then we do the math here. And we'll say 5.1 divided by 207.2. And we get 0.024. I'm going to write some extra numbers on here. That's how many moles of lead. Now look, 1, 2 sig figs, 1, 2, 3, 4 sig figs. So I need a number that has 2 sig figs, and notice the number over will round him up. 0.025 moles is actually the correct number. Now you have 4 examples to practice yourself. Well, we just did the top example. You've got 3 more examples to practice yourself. This one is moles into grams. This is grams into moles. And this one is grams into atoms. So to do this one, you're going to have to take your grams of lead, and just keep in mind, you can't go jump straight to atoms. You have to go moles of lead, and then you have to go from moles of lead until atoms of lead. All right, so go ahead and go do these ones on your own.